Good morning, good afternoon, depends on where you are. Can you hear us? Can you just type in the chat dialog if you can hear us? Yes? Excellent. Good morning. Yes, we can hear. Great. Welcome to the RPKI webinar. Today it's me, Natalie, and there is Gerardo sitting next to me. So how this will go about, you're logged into the system. I'll explain a little bit how the system works and what you can see where. First of all, this is an interactive webinar, and that means you can ask questions at any time. You can use the chat dialog for that, and Gerardo will look after your questions. So at any time, ask anything. Then you will see our faces on the back. Well, mostly my face. Yeah. On the right-hand side below, you will see the RPKI files. You can download the slides there in case you later on want to review the slides again. On the left, you will see the acronyms that we will use. If you have other acronyms you want explained, please use the chat dialog and Gerardo will explain them. Another thing that's important to realize is that this session is being recorded. So we might publish it, or we will publish it afterwards on our website. And we will also send you the recording, so if you want, you can share it with your colleagues. The last dialog button or field you can see on the left is a poll. So like I said, it's an interactive webinar. We have some questions for you later on as well. If you're all ready to go, then I'm ready to go, and I will share my screen so you can see the slides. So here we go. Let's get up the slides. And the slides are here. Yes. Okay. So let's get started. First of all, a little bit of an introduction to RPKI. I don't know if you guys are all familiar with RPKI or to which extent. So to get everybody on the same page, we'll do a quick introduction. Bear with us. A little bit, because RPKI, Resource Public Key Infrastructure, is all about securing BGP. And how BGP works in a nutshell is that you have two networks. In this example, network A and network B, and they both have a prefix. Now, if A and B want to exchange their traffic, they have to be telling each other who they are and which prefix they have. So B announces the prefix to A, and A, the routers of A, will put that information in the routing table, and vice versa. BGP in a nutshell. Of course, there are a lot of other factors around it, but bottom line, this is it. You exchange traffic, you have a routing table. Now, the whole thing is, how do you know if A is the legitimate holder of 193.xxx? How do you find that out? Because in the past, everybody knew each other, so you could verify that information quite easily. Nowadays, not so much. So how do you secure that? How do you make sure that company A is the rightful holder of that prefix? You can check that information in what we call an internet routing registry. And in our region, we use the right database for that. So if company A is the legitimate holder of a prefix, you will find that reflected in the right database. And a lot of parties put then in a route object or a route 6 object for IPv6, where they say, I am the rightful holder and my prefix will be originated on the internet from this and that AS number. So you can verify that. Also for B. Now that internet routing registry, I'll get to that in a moment, because that is the basis of secure routing, but there are some issues with that. Issues like accidents, they happen all the time. If you run a BGP network, I'm very curious to know if you never ever made a typo that caused a route leak or an outage. So most of the incidents and the accidents on BGP are because of fat fingers. You will recognize that. It gets a bit more dirty if there is a case of policy violations. For example, you start announcing a prefix that's not yours, or you intend to filter something, like in the case of Pakistan Telecom back in 2011. It's a very old example, but it was quite a big controversy. What happened there was that Pakistan Telecom wanted to filter out YouTube, but instead hijacked their prefix, basically making YouTube for the world inaccessible. Now we see an increase in these policy violations, and an example of last year, more recent, is a BGP and DNS hijack in April, where a small ISP, by accident or malicious, it looks like malicious, but you can never tell, started to announce 1,300 IP addresses from Amazon and Amazon's DNS service. And the problem there was that it was not just a BGP hijack, it was also a DNS hijack. Because one of the websites that was hosted on the Amazon DNS, myetherwallet.com, had a DNS hijack. And people basically went to that website to maintain their cryptocurrency. They got a fake website with a pop-up saying this website is not trusted. But what do users do? They click OK and they proceed. So that resulted in basically the theft of $110,000 in just 2 hours of cryptocurrency that went away. So there's now, in the world of hijacks, there's now an economic incentive as well. So we see that more and more happening. How often do we see that happening? Well, there is some research being done by BGP Stream. And they saw last year only more than 12,500 incidents. And that's not only hijacks, that's also outages. But there were a lot of hijacks involved there. A lot of AS numbers were involved there, and 1,300 AS numbers caused one incident, but more AS numbers, of course, were victims. So how do you go and protect your own IP space? That is what RPKI is all about, really. So as I said, people use the Internet Routing Registry for that. Now, the RIPE database is not the only routing registry out there. There are approximately 30 different databases out there that people use to create route objects. And the most used ones are the RIPE database and RADB, Routing Assets Database. And RADB is a commercial database where you basically pay $500 a year and you can put in anything you want. So you see a problem there already. The RIPE database does the verification of holdership to check if you're the legitimate holder of that address space by using that maintainer. So you have to use a maintainer with a password or your SSO to claim that you are the holder of those resources. RADB does not have that mechanism in place, so you can create any object you would like. And lots of the other Internet Routing Registries also do not verify the holdership. So this already is why the data in those Internet Routing Registries is polluted over time. By default incorrect sometimes, and it gets worse over time as well. So that is the problem statement, and that with that scenario, RPKI came about because people claimed that IRR data cannot be fully trusted. For the RIPE database in our region, it's pretty much okay. There is an accuracy of what we see in BGP versus what people put in the RIPE database of around 85%. But there is also data in our RIPE database that does not match with BGP, and that data is mostly for resources outside the RIPE region. Also, not every regional internet registry, like RIPE, has a database. So for example, LACNIC, Latin America, they never had such a database for root objects. So they can't do the verification, leaving that up to operators and RADP. So in 2008, the internet community, by terms of the Internet Engineering Task Force, which is a platform where all the RFCs are being made, came up with a new way of doing things. And that new way of doing things was called Resource Public Key Infrastructure. And it uses quite a hierarchical model. It follows the hierarchy of the registries. So there are 5 trust anchors, 5 root certificates of the 5 regional internet registries. And they are supposed to know, we are supposed to know, who are the legitimate holders of those addresses. And with that information and the addition of public keys, you can build a chain of trust. And with that chain of trust, you can then create authorized statements from resource holders with public key infrastructure. If I'm going too fast, don't worry, I'll explain later on in detail. You can do basically the same as a route object by saying ASN 123 is authorized to announce my prefix 123.123.123.123, etc. Signed, the legitimate holder. So going back to that chain of trust, so like I said, there are 5 root certificates. RIPE NCC has one of them, and it's a self-signed root certificate. So it has a public key and a private key, a signature, and it covers all resources. And so have all the 4 others. With that root certificate, we can basically have an LAR opt in to create their certificate. So you certify your resources. So a digital certificate that you can get from RIPE NCC or you can create yourself, you can basically set up that certificate to sign your resources. So far, so good? Looking at Gerardo, tough questions? No? Okay. If anything is not clear, just ask it. Don't forget. Because now we're delving into ROAS. Before we do that, I'm just curious to hear from you. Who already created their ROAS? Can you tell Gerardo if you already created your ROAS? I'm going to explain what it is. If, in case you haven't, don't worry. After this section, you will be able to do it. Yeah, some people are typing. Cool. Basically, in RPKI, there are 2 things you can do. The first thing you can do is create your root origin authorization, basically your route objects in RPKI, making a statement that you're the rightful holder of the space. So that's one, that's the signing part. And then you've got the validation part. And in this webinar, we will cover both, but the signing part is what we really ask every RIPE member to do. So get started with this in case you haven't done that yet. A ROA is route origin authorization, and all our members can create a ROA for each one of their resources. So let's say you have an IP range and you announce that in BGP, and you want to make a statement saying, I have this range and it is being originated from this AS number. That is what you call a ROA. It's a digitally signed route object, as you can see it. You can create multiple ROAs for an IP range. So why would you do that? Well, for example, because in normal life, you have, let's say, a /20 in IPv4 that you want to originate from a specific AS number. But in some cases, you want to be able to announce a more specific /24 from a different AS number. You can already create both ROAs in our system. So that's what I mean with ROAs can overlap. So a /24 from a /20. So what information is in a ROA? Of course, there's the prefix, and only the holder from that prefix can create a ROA. Then the origin ASN, and that's a free text field. So you can put in any AS number you want to use to originate your space. Now there's a little caveat there. Of course, private AS numbers cannot be used in a ROA, and some reserved AS numbers can also not be used in a ROA. So that is a bit the idea. And then we have something new and something special, and that is confusing for a lot of people. It's called the max length. And the max length is an attribute in a ROA where you specify the maximum prefix length that you allow for this ROA. So I'll have an example for that in a second. Because this is a part, the max length is tricky for a lot of people. And that's where the most mistakes are being made. So if we go back to that chain of trust, the overview, we have the all resources certificate from RIPE NCC with the public key and the signature, and we use the root's private key to sign the LAR's resources. And then, after you have done that, you can create your ROAs with your prefix and your AS number and your max length. So this is the total picture for all three elements in RPKI, where for you the most important ones are the LAR certificate and the ROAs. Voila. Now, RPKI was designed to be completely distributed. That means that it is a good idea to handle your own keys and your own key rollovers. But already in the early days, we discovered, asking a lot of operators if they would do that. And they said, nah, not really. I find this very difficult and tricky, and things might break if I do it. So RIPE NCC, why can't you offer a hosted RPKI solution? So that's what we built. We have a hosted RPKI solution where basically in the LAR portal, you just click and get your certificate. We take care of the key rollovers. You create your ROAs, but we still maintain all the crypto stuff behind it. So that lets you focus on creating and publishing the ROAs. It's the easiest way to do things, but of course, it's not exactly how RPKI was intended. So if you really want to do it according to the specs in the RFC, you run your own certificate authority with your own software. Now, at the moment, that's still in the baby shoes. Our friends from NLNet Labs are working on software for that. It's called Krill. They will launch that somewhere early next year. So for the moment, we say, okay, if you want to have your certificate, create your ROAs, use the hosted system, the hosted by RIPE NCC, and later on you can always set up your own non-hosted RPKI and look after your own keys and your own key rollovers if you want, and if not, you can just stick with our hosted system. So let's say you have not touched RPKI yet and you want to start with it. If you go to the LAR portal and you log in, on the left-hand menu, you will see 3 items. And one of the items there is resources. And if you click on that, you will get to the RPKI dashboard. And when you log in to the RPKI dashboard, or you go to the RPKI dashboard for the very first time, you will see this, our terms and conditions. And here you can select what you want to do. If you want to go for the RIPE NCC hosted certificate authority, so that we do everything, or you can choose the non-hosted. Now, let's say we go for the hosted and you accept to create your certificate authority, then in the background a lot of stuff is being done, and you will have a certificate for your resources. Then you can do the cool stuff. Then you can create ROAS. And for that, I think I'm just going to demo that in the LAF portal, so you can play along if you like. Then I go outside the slides, and I will go to the browser. The browser is here already. So I went to my.ripe.net. I can sign in. Let's do that with my own credentials, as you should. Now you will find out my email address as well. I sign in. And this was the menu I was talking about. So you've got resources here. If you click on that, you will see the RPKI dashboard. Click on that. And there you have it. Now, I already have the certificate, so you will not see that first page. But this is the first thing that you will see. So we will show you what you are currently announcing in BGP, and if there are ROAS or not. Now, there are already 2 ROAS. I cannot play too much with this because this is RIPE meeting address space. But if you log into the LF portal, you will see your BGP announcements that we see with our RISC platform, and so our routing information system. We can see what you are announcing and by which origin AS number. If you think that this is correct, what you see here, you will see the current status unknown. And unknown means there are no ROAS. So then you can click the button Create ROAS for selected BGP announcements. And once you do that, automatically the ROAS will be created for that. You can also say, okay, I want to create a ROA before I start announcing a specific prefix. So let's see how that works. Let's say I'm going to create a new ROA, and I want to use a different AS number for a more specific prefix. It has to be my own prefix. You cannot type just your neighbor's prefix in here, because otherwise I'll show you it will not work. Immediately it will start complaining. See? Prefix must belong to your certified resources. Okay, let's do that then. Now, the complicated part here is most specific length allowed. So what do you want to show on BGP? How distributed are you going to, how deaggregated are you going to announce this /48? Are you going to allow announcements of /64s? That's fine. Probably not for the routing table, but that's a different story. But it is in RPKI, this is allowed. You can also say, I want a max length. Not that. T2. So it gives you clues, like what I just showed you. A 44 is, of course, the max length is longer than the prefix length for IPv6. Anyway, so it gives you clues about what you can and cannot do. And then I click on the Save button. Then it tells me to review. So it's not immediately live. I'm going to review it. And if I think, okay, yes, from this origin AS number, I allow this /48. And in BGP also, it would be possible to see more specifics up to a /52. Yep, that makes sense. I'm going to publish. And there you have it. Now, it's not causing problems. The bubbles are green here, but this is a 0 because it's not seen in BGP yet. ROA is fine, but it's not seen yet. Yeah? So far so good? Yes. Okay. Let's go back to the slides. So this is what you would see typically if you have never created a ROA in your life. Then we see the BGP announcements, you can see them, and all the status is unknown because there are no ROAs. And then you can just select the different announcements, create the ROAs, and there they are. Review and publish changes. Yep, and publish them. Then they disappear from the list, but you will find them again there. Yeah. Okay. Here in this case, what we see in BGP is a /32 and not a /48. So you can say, okay, I'm going to create a ROA for that /32 instead of that /48. So then you create it. Going back to those max lengths, because that is confusing and people do it wrong. Let's say you have a /21, IPv4, let's keep it easy, and you say the max length is a /21. That means that only in BGP RPKI announcement is valid for that /21, not for the 22, not for the 23s, not for the /24s. So if you start announcing a more specific from this block, likely operators will drop it when they do origin validation because they see that as invalid. It goes against what you stated in the ROA. So if you want to start announcing a /23 but allow a max length for a /24, you basically validate that /23 and both /24s. If you have any questions about this, ask Gerardo, because I'm going to test your knowledge about this in a moment. So the ROA, the BGP announcement is only valid for the max length that you have set. Clear? Okay. In this case, we set the max length for a 23, only the 23 is valid. Okay, now it's your turn. We have a question for you. I'm going to sneak peek. So have a look at the poll, read the question, find the matching answers. I'll give you 2 minutes to do that. I see a question. Yes. So AJ, you need to delete the ROA. Would you need to delete the ROA for the max length of a /21? If you need then to make a max length 24. Yeah. So just delete the ROA, create a new one with the prefix /21, max length /24. How are we doing with the poll? Yeah. Wow. Nice. Tricky, eh? Subnetting. Yeah. If you don't do it every day. So which 24 belong to that /23 again? Yeah.
Changing your mind.
Yeah, change your mind. That's fine. So you have a ROA for a /23 with a max length /24. Which BGP announcements will be seen as valid? Well, indeed, the /23 itself, yes. And most of you think, okay, the underlying /24s as well. So not the /21. You're very good, very awake, all correct. No wrong answers there. Excellent. So we talked about ROA creation. If you have not done that, please put it on your to-do list because it protects your network from a specific set of hijacks. Not all hijacks, no route leaks, but a specific set of hijacks will protect yourself against. The second part is the validation, and that is what operators can do to check the information that everybody put in the system when they created the ROAS. So RPKI needs two actions, I explained to you already. You have the signing, creating of a route, or authorization record, the ROAS, and then you have the validation. So this section talks about the actual validation. How do you do that? So you need a piece of software to begin with. And you need software that has access to all the repositories of these 5 root certificates, those trust anchors, and information to feed into that validator and to make the routing decisions. So it is software that creates a local validated cache with all the valid ROAS. So it also validates the chain of trust, so it checks all the certificates, all the keys, and talks to your routers using the RPKI RTM protocol. So what do we have? We have a relying party. That's what we call you guys, a relying party, because you rely on the stuff that people put in the repositories. And there are 5 trust anchors, one from NCC, one from Erin, APNIC, LACNIC, and EPRINIC. So the database with all those ROAS that we have, that we create, Erin has a similar one, APNIC has one, LACNIC, EPRINIC, and they all talk to the validator, your piece of software, that talks to your router. And you can make then decisions based on that. So what you do is you feed into your router, or basically into the validator, that whole list of ROAS, and you check those statements versus what you see in BGP and see if it matches. In case there is no ROA, it's unknown, you can't do anything, so yeah, you leave that traffic be, you let it go. But if you see a valid ROA, a valid BGP announcement, then you already know, okay, somebody makes a statement, this information is correct, excellent, I'll leave it go on. But what if you see a BGP announcement that does not match the statement in a ROA? Then there is something potentially quite wrong. And that is where we recommend operators to drop those prefixes. And that's what we call origin validation. 2 pieces of software well, there are more at the moment on the market, but 2 popular ones is, first of all, it's ours. It's on GitHub, you can download it. We released version 3.1, it's stable release. We released it after a test of around 2 months. We had some issues with previous versions. If you are running a previous version, I do recommend to upgrade to 3.1 because it's a lot smaller in size and a lot faster in the calculation. It's Java based, it has a web interface, I'll show you in a second, and it has whitelist functionality. I'll go over the rest. Another one that is almost 2 years old now is Routinator. It's from NLnet Labs, also on GitHub. Both are open source. This one is built in Rust, and it's built to be small and scalable. So where ours is a bit bulkier, a bit heavier, it comes with a lot of features and a web interface. If you need small and scalable, small and fast, then Routinator is your friend. However, a lot of operators use both for redundancy in the network. So here is the grand scheme of things. You have the RER repositories with all those ROAS. They are fed into this piece of software that you run yourself, validator. The verification of those ROAS is being done there. So the whole chain of trust is being checked. The output goes into a validated cache. That information is sent to your routers, and there the BGP magic is being done, and you can make decisions. Are we still good? Yeah? Okay. Then, ROA validation. So that last mile, as I call it, of origin validation. So the routers receive that information, and then you have to make decisions. And those decisions are all yours. So the validator does not make those decisions. It's all up to you. You can accept or discard the invalid BGP announcements. If you find it scary to start dropping immediately because you don't know exactly what you will lose, as a temporary measure, you could, for example, set a local preference on the invalids. Don't keep that there. Some people just do that and leave it, but then you're still not dropping those invalids, so that's still in the end quite pointless. Other big providers have done it already, like AT&T in the US and in KPN and Access for All in the Netherlands. And they send reports about what happened when they start dropping invalids. They claim that overall they lose around 700 routes from their global routing table. And those 700 are out of the, what is it nowadays? 800,000 routes in the global routing table. So that's just a really small portion. Do they get customer calls? They had maybe one. AT&T, I asked them 2 days ago. Since June, they had no customer calls. And if they get a customer call, it's because the customer can't reach somebody else's network that made a typo in their ROAS. So if you contact them, or somebody contacts you to tell you that there's a typo in your ROA, please fix it as quick as possible, because otherwise you are unreachable. Now, another thing that confuses people is what is a valid ROA? Because we use valid BGP announcement and valid ROA, and we use it. Sometimes we say the wrong things, but what we mean is we can have a valid ROA and an invalid ROA, and the reason why a ROA is invalid would be because the certificate is broken. Maybe because something's wrong with the keys. Maybe because a prefix was transferred to another party. So a ROA can be valid or invalid based on the certificate. It says nothing about BGP, because a ROA can be perfectly valid, correct with the certificates, but it does not match BGP. And this is the second bar I'm talking about. That's this bit. Yeah. Where you have a valid BGP announcement because it matches a ROA. It can be an invalid BGP announcement because it does not match a ROA. And it can be unknown in case there is no ROA. We're good?
Mm-hmm.
Yeah, we're good. Okay. So to summarize, we can have an invalid ROA, and that means the ROA in the repository cannot be validated by the ISP, so it's not included in the validated cache. So an invalid ROA does not even get to your router. An invalid BGP announcement, that there is something wrong with BGP and a ROA that don't match, or the max length doesn't match. If there's no ROA, we know nothing, the status is unknown. And then there's whitelisting. So let's say in this holiday period, you create a ROA and you made a typo and your network is dropping from the table and you went on holiday. So let's say I made a typo and Gerardo is my neighbor in BGP and he knows I'm on holiday and my network is falling from the table and nobody else has access in my company to the LAF portal. What Gerardo then can do is create in his validator a whitelist entry saying, this prefix from Natalie's network, from this AS number, should be trusted until Natalie is back from holiday and she fixes her ROA. So how does that work? I'm going to show you that as well. Do I still have time?
Oh, yes.
Yep. Okay, cool. So how to whitelist? I'm going to show you. Let's say you installed a validator. And I have a public one just for demo purposes, but it's my view of the world, so don't use it. Okay. Oh, probably HTTPS. Okay, so if we go to my validator, so our validator comes with basically a web server or a web application where you can see the status of things. If you run that, you will see a feature here called whitelist. Click on that. And Gerardo does that, for example, and he can say, okay, this prefix 193.25.0.0/23 from Natalie's AS number with a prefix length of /23. And then you can say a comment. So you can set a comment there saying, okay, why did I put it there? And then you can click add. By doing that in your validator, it will ignore my invalid and override it with as valid. So I allow that network. I also asked the operators who do origin validation how often they use this. And they typically say, I've done it once or twice in an emergency. But normally, if I contact the network to fix their ROAS, they fix it within a day anyway. So I'm good. Other features that we have in our web UI, you can see the APNIC. There's something wrong with the APNIC trust anchor. That is probably because they run national internet registries. And there are some issues sometimes with, so they have national internet registries like Taiwan and China, and I have no idea which this one is, but this one gave it a fail, unfortunately. Now, typically it gets all fixed pretty quick, so if you look back in a few hours, it tends to be fixed. Here you can find a list of all the validated ROAS. As you can see, there's quite a number of them. With the max length and which trust anchor it falls under. Ignore filters, so you can use filters to exclude ROAS. You can whitelist, and you can see what the validity is for a certain prefix. So what you would drop if you would drop invalid. I have a question. Any plans for role-based access control? No, we don't. So the thing is, we don't have role-based access control in the LAF portal that much. So we've got only the admin and we've got the user, but we don't have it in the validator because this is operational. So it's read and write, I'm afraid. Setting up an own RPKI validator is not suitable in our case at the moment. Can you provide a hosted one without whitelist possibility then, of course? Yes, You can have a look at Octo RPKI. Octo RPKI is run by Cloudflare. Okay, and it provides you with a JSON output. But yes, so however, that goes completely against the idea of RPKI, where you're in charge of your own network. So I do strongly recommend to run your own validator if you want to do origin validation and not rely on somebody else's view of the world, because you have no idea why somebody else whitelisted something or not. Or yeah. Okay, AJ, this may be an obvious question, but does having a role object in the database have influence on the ROA, or are they exclusive from each other? Yes, they are completely exclusive. There is no relationship between IRR and RPKI. However, you're not the first one who thought about this. So there is currently a policy proposal in the RIPE database working group that says, and this is only for objects outside of RIPE in the RIPE database. Can you still follow me? So somebody created an Efrinic prefix in the RIPE database. The policy proposal says if there is a ROA from Efrinic, the Efrinic region, that says it should be A, while in the RIPE database it says B, then the RIPE database object should be deleted. So that is a policy proposal. I just wrote an impact analysis, but this is the first time somebody tries to tie the RIPE database and ROAS as an overriding mechanism for each other. So that's new. But in principle, there is no relationship. Does that answer your question? Yeah? Cool. Keep the questions coming while I go back to slides. So that was the whitelisting I showed you. Yeah. Jürgen, it's called Octo RPKI. Let me see. Your Google skills are probably better than mine. This is the RTR. Okay, let me have a Octo RPKI. There you have it. Yeah. So on GitHub. Yeah. Okay. Now we have another poll for Gerardo to open. Let's have a look at this one. We have our routers spotted something interesting. They saw an ASN announcing a prefix and the status is invalid length. Question is, look at the announcement preview. So that is the top one. Let me show you this one. Why is the status invalid length? And select the answer. Have a look at the relevant validator ROAS. Tell me what the problem is here. This is more difficult. So what we see in BGP is a /48 coming from AS 35470. I'm really happy. Yeah, what Gerardo said. I'm really happy. So nobody claims that there is a bug. Okay, you're done? Okay, yeah, thanks. I saw that coming. Okay, yeah, okay, cool. So the max length is wrong. Yes, indeed, the max length is indeed wrong. What we see in BGP is /48 being announced. But if you look at the ROA, then you will see that there is a prefix for a /32 with a max length of 32. So that /48, according to that ROA, should not be announced. But if you look at the second, so your answer is correct. But if you look at the second entry, you see that there is the same /32 with a max length of 48. So in that case, yes, the /48 is correct, but the AS number does not match what we see in BGP. So in this case, it looks at the covering prefix, which is the /32. It does see the correct AS number, but the max length does not match. So in order to solve this, operator should remove this ROA, actually both, and create a ROA for, if they want, a /32 with a max length of 48 from that correct AS number. Or create a separate ROA. As I said, ROAs can overlap. It's perfectly fine to have two ROAs, one saying /32 with a max length of 32, but another ROA saying for that AS number, the prefix should be a /48 with a max length of 48. That's fine as well. Complex stuff. Like I said, the max length is a tricky one, but in this case, the problem indeed was the max length. So we're almost at the end of the, yeah, thanks. We're almost at the end of the webinar. The thing is, RPKI is not a magic box that fixes all problems. As I said, only a few types of hijacks can be mitigated. What it does offer, first of all, by creating your ROAS, is the protection. You make a statement about your resources, which is a good thing. Second, more and more operators are going to honor those statements by dropping invalids. But the problem still is route leaks. You can't prevent from this. So the paths are not validated. So there is a lot of work at the moment going on in the IETF because operators do feel the need to basically validate that whole path in BGP. So there's BGP-SEC. It got standardized, so it has an RFC number now after 10 years of being discussed. Will this be the future? I don't know. It's kind of heavy on computing power and resources from a router perspective because it is public key infrastructure on the whole path. Kind of heavy. And there are different solutions like ASPA and AS cones where you make statements about the rest of the path your traffic should go. But we're not there yet. So we keep you posted. That's what we do. And that's it for us for now. If you have any questions, you can always contact the training team. You can email rpki@ripe.net. You can also email me. Jorda's giving my email address now. Yep. I hope you found this useful. We will do another one in a few weeks. And yeah, if you have any questions, type them now or send them to us later. And good luck setting up your ROAS and looking at origin validation. Thank you very much. Bye.